I am finally starting the video series for hair loss that I've been talking about doing for a very long time now. So this again is going to be an introductory video into the science of hair loss to give us a basic understanding. Many of you guys may know me from some of my other videos, Gerald Crochet, or from my username on Hair Loss Help, Hair Loss Talk, and some of these other forums as Crochet G. And it is pronounced like the knitting crochet. You wouldn't be surprised, without fail, every year at the international or the ISEF competition. I'm always presented when they call me up as, "Would Mr. Crotchet please come up?" So it's not crotchet. The ET is makes an A sound, so it's crochet like the knitting. But anyway, beyond that, I'm going to give a little bit of an introduction, my experience with hair loss, how it's affected me, and then reinstate that this video is the first in a video series. So with that said, I think that doing it this way is beneficial for a number of reasons, but I would like this video to be limited. I'm going to try to the best of my ability not to talk about treatment options in this video, but simply analyze the science behind hair loss. Because us having a basic understanding of the information that's out there, of what's happening, how we're losing hair, that whole process, the science behind that is so crucial. Now, in your mind, when you hear me talking about this stuff, you can begin to formulate, how you think, the possible methods of treatment. You might be able to start formulating, well, how can we stop this disorder from going to execution? How can we stop miniaturization or the hair loss? So you might be able to develop these things as I speak, but remember, the purpose of this video is simply for us to discuss the science of hair loss and treatment options and some of the vast majority of the resources out there to help with this disorder will all be discussed in later videos. So they are soon to come, but we need to pretty much hit the science pretty hard in this video so we can all come to an understanding. So, a little bit of self-introduction. As you guys know, my name is Gerald Crochet. Made some videos in the past talking about the science of hair loss and some of the more advanced treatments that are out there. But I'd like to give a little bit of background. Of course, I am, while I still have a head of hair, remember I'm very, very young, so this hair is hair that I have left. So I want people to, realize that. And I have suffered a great extent of hair loss. And I would say, for me, it began very early on, about when I was 17. So the purpose of this video, for me, is to get all the information that I've gathered over several years of research online, going to all these different communities, put them into one nice package so that people who are just starting to, want to do something about their hair loss, learn more about it, can have a very valuable resource where all of these resources that might take a long time to compile are all in one very readily accessible form through this video. So with that said, my hair loss began very early, around the age of 17. And I really began to notice it. I was part of the Arkansas School for Mathematics, Sciences, and the Arts, which is a kind of specialized school, more boarding school-like, where there is a facility connected to the academic building where you have residential life of the students. So with that said, it was very college. My high school experience was very college-like, and it all began really over a debate between me and some of my roommates over the massive amounts of hairs that were found clogging the drain, at the end of each week. And we'd always debate back and forth, where are these coming from? And of course, I had no idea that I was losing hair in any sort of way, so I always brushed it off and said, oh, it's one of those guys. And it wasn't really until I came to the realization that, as I run my hands through my hair, so much of it is coming off. It's that real shocking feeling, that realization that, yes, those hairs were mine, and I really am going through this. And very early on, I had extremely thick hair, and this is a story I hear from a lot of people that begin to lose their hair very early on, that they really started out with extremely dense hair. And I was always reassured in the fact that, I would just think to myself whenever things would get bad, well, at least I have really good hair, and I'm not in any chance of losing my hair. And it was really shocking to me when I found out that yes, this is real. I really am losing my hair. It was so debilitating, and it has such an emotional impact on young teens that are going through this. So the purpose of the video is really focusing on those individuals, but of course everyone can benefit from this just through the science and the understanding. So basically I would like to go ahead and get some real basic terms out there for people who are just getting involved in this. Of course, if you ever hear the term AGA, we're talking about androgenetic alopecia, or rather balding that is due to androgenetic, and there's a genetic component of that, which we'll talk about. So that's what AGA stands for. You'll hear other things like telogen effluvium, anagen effluvium, male pattern baldness, or MPB. Of course, it's called male pattern baldness because, as I'm going to get into later in the video, of course, there are certain patterns that hair loss usually progresses in. You'll hear things like terminal and vellus hairs. That's simply discussing the state at which a hair is. So let's talk about what hair loss is. To do that, we really need to kind of get into the anatomy of the hair follicle and skin. So I've kind of drawn up here. Of course, we need to understand that the hair follicle is a actively dividing component of the scalp. And when we begin to analyze what's happening or what is going wrong in our case with male pattern baldness, it's very important that we visualize this so I can point back to different locations when I talk about the science of this and what's happening. So of course here we've got the hair follicle, the dermal papilla, the sebaceous gland, which is responsible for the sebum, which helps kind of protect and insulate the follicle here. And then we have the epidermis and the dermis, and all of this is going to come into play. So let us talk about how hair cycle, because hair cycling is such an important aspect of understanding all of this. There are different stages of hair growth. Well, rather I'll say this, there's one stage of hair growth and there's a big cyclical process that hairs go through. Those different stages are known as anagen, catagen, telogen, and exogen, where the hairs actually shed out of the follicle. So we need to understand that in a normal individual, you have certain percentages of the hair on the scalp in these different phases. And in a normal person where they don't go bald, they stay in these kind of fixed percentages where around 90% of them are in the active growth state and about 10% of them are in the telogen phase where they're resting, waiting for a new anagen follicle to push the hair out. And that is kind of distributed evenly across the head so that these hairs, when in telogen phase, you don't ever notice an apparent pattern to it, or you can't really pick up on the fact that those hairs are lost. That's in a normal individual. So obviously right there you can begin to picture that in people like us, there is, first of all, a higher percentage of hairs in the telogen phase, and they are more highly synchronized and in specific locations that you thin in. But we also need to understand this real basic principle, that hair loss is not the loss of the follicle after a round of shedding. So when you see a hair that comes, if you run your hands through your hair, you see one in the sink, it's not like you have lost that hair. That hair is simply gone through telogen and exogen and will be replaced by a new hair. So then what is the problem? How is there development of a condition where you lose hair if hair is continuously replaced? That's where miniaturization of the hair follicle comes into play, where physically the follicle is miniaturized every time it goes through a cycle. So let's talk about some of the anatomy of the hair follicle. It's important to realize that at the base we have a kind of cellular matrix that's actively dividing and depositing cells that build a growing hair, and of course it extends outwards at about 1 centimeter every 25-28 days is the usual growth rate. So during anagen phase, this is happening, where the hair is actively growing and increasing in length. That process is usually a very long-lasting process of 2 to 3 years, whereas the catagen, or the transition between anagen and telogen, the resting phase, is about 2 to 3 weeks, whereas the telogen phase is about 3 months. Now, it's important to realize that, of course, you have, in normal people, the vast majority in that continuous growing state. And that when a hair transitions into telogen, it isn't necessarily expelled right then. Active division of the cells at the dermal papilla is simply stopped, and there's a final deposit of those cells, and it gives the hair follicle a root base, or you'll see a clubbed. If you ever hear someone say the term clubbed hair, that club is simply a deposit of cells on the hair fiber that keep it embedded in the skin during the telogen phase. And of course, if you comb through it, you have the potential to pull it out, and that's where, in shedding, if you notice, you'll see that little club. That means it simply was a telogen hair. You won't be shedding anagen hairs because they're deeply embedded into the skin, and they're of course held onto, whereas telogen hairs are the ones that have the potential to leave the scalp. So that's another thing. Anytime you see hairs during your hair loss that are pouring out, it may be quite alarming, but remember, those hairs are all telogen hairs, and they were put into that phase because they are no longer in a growth phase, and that's a big problem we're going to talk about. So the main problem with hair loss is this miniaturization aspect, whereas as the hair goes through cycles, when it is back in the growth phase, after a cycle has gone through, it has gone through telogen and exogen, there is no longer hair follicle there. Well, not follicle, but hair there. Whenever it begins developing, it is theorized that in late catagen and early anagen, that the hair follicle is susceptible to a lot of outside forces that can influence the growth phase. Now, during anagen, miniaturization is not affecting the diameter. It's during that initialization of anagen at which miniaturization occurs. So you can see that through successive cycles, miniaturization, or making the hair smaller with each cycle, eventually leads to you having less, visually less apparent hair, and that is the main problem. So if you ever see people's bald spots, well, they may still have a lot of hairs there. They're very fine, they're very vellus, versus a terminal thick hair. Now, eventually, those cycles will cycle all the way through until there is complete death of the follicle. But that takes, it's a lengthy process, and that's when you see people that are completely bald. So now let's talk about a little bit of the science behind this. And in order to understand this, I really want to talk about cell biology in terms of the central dogma. And by being able to understand this, review that basic biology, it'll make a lot of the science make more sense. So I'm going to spend a little bit of time and review some cell biology, or the central dogma of biology, which is turning DNA into protein, or taking this genetic code and making use of it in the cell in the expression of proteins. And that really has direct implications when we're talking about a genetic disorder such as this. We know male pattern baldness, or androgenetic alopecia, of course, has a huge genetic factor. So I really want to go back and let's view how genes are expressed. So hopefully we can all see this on here. So of course we have a cell. We all know that a cell has a nucleus. Within that nucleus, the DNA is present. The DNA is simply, think of it as a bookkeeping or a library for various instructions of how to make proteins. And proteins can have a number of forms. They can be structural, they can be enzymes, they can be gated channels. Basically, think of proteins as machinery, and the nucleus and DNA as the instructions to make that machinery. So all of that will be present within the nucleus. So actually, let me get something to erase this with. So, as we know, DNA is a double helix, which I'll represent here. And there are many bases, which give us the actual code of the DNA. And their sequence is very important. But let's talk about the expression of that. So RNA polymerase will come into the nucleus, into the DNA, and once it is opened up to where one strand of the genetic information is exposed, RNA polymerase can bind to it and begin to produce a single nucleotide strand, which is a copy based on this genetic information known as RNA. So you're taking the information on a double helix that is simply these base pairs. DNA is simply a form in which this information is less likely to be destroyed or altered, and you can still get all the same information from RNA. So RNA is going to be our primary source of moving this genetic information, which is kind of stored in the library in the nucleus, and making something out of it. So once we get this RNA strand, there are, of course, these nucleotide bases, which we can think of as the instructions. Now, there's a lot of processes in here that I'm totally skipping. There's RNA or an mRNA package or processing where you cut out introns and you're leaving the exons. There's all sorts of ways that you can vary the expression of genes. But let's just look at it this way. So we have messenger RNA, and a ribosome will come along and bind to the messenger RNA, which of course has been moved outside of the nucleus into the cytoplasm, or into the rough or smooth ER. But nevertheless, we have messenger RNA, and each of these three base series is a codon. And what will happen is a ribosome will bind here, move along, read this, and as it does, something known as transfer RNA will come in carrying an amino acid, and it has an anticodon which matches this codon base pair here. It'll move in, and as this moves along, and transfer RNA moves in, moves out, it deposits these amino acids. Alright? So as this moves along, I'm going to draw it over here so you can picture this. Behind it, a form or a chain of these amino acids is being produced as it moves this way. So these amino acids, erase this, once produced, there are many different amino acids, and because we're dealing with chemistry here, this is the primary structure of a protein. This chain can then fold in on itself based on the chemistry and the attractive or repulsive forces between different peptides or different amino acids. So you get all sorts of complicated structures. The way I imagine this is, imagine a Mardi Gras bead strand if you cut that open. Imagine all the different combinations or ways you could glue that strand together. Well, that's exactly what happens. So this long chain will form 3D structures by folding in on itself, looping back around, and you get really complicated structures. So with that said, you can see how we've gone from DNA to mRNA to protein. And of course, the thing is, on protein, this is really when protein can be multiple different things. But in our case, the protein that we're going to be concerned with are enzymes such as 5-alpha reductase and the androgen receptor. So you can understand if you have a problem or genetic disorder, it can present itself in a physical way. So with that said, let's talk more about hair loss. So one important thing that should definitely be said are the impact of androgens into androgenetic alopecia. An androgen is a male hormone. Well, it's actually present in females too, but in males it has a much greater impact in terms of development and bodily functions. Those are things such as testosterone, dihydrotestosterone, and all of these have an impact on the hair life, the hair cycling, and in our case, with our genetic factors, they lead to the hair's death, or the miniaturization. Now, don't immediately assume that androgens are the enemy. Androgens are necessary for normal body chemistry. They are found within every individual, and it's not like androgens are the problem. It's not like people with male pattern baldness have androgens where others don't. It is present and they're normal within every human body. So they're not necessarily the enemy, but in our case, androgens can signal miniaturization of the follicle. And to understand that, we need to realize, let's look at a cell here. I'll draw a bunch of different things. So we have testosterone, which can enter the cell, and there are, going back to this whole protein idea, there are enzymes, which are proteins, that can convert testosterone into a more potent androgen, known as dihydrotestosterone. So it's simply converting testosterone to another form that is more potent, and in our case, has more effect on our hair loss. And it is known as 5-alpha reductase. Converts testosterone into dihydrotestosterone. And dihydrotestosterone is the most powerful male androgen, and in our case that is a big concern, because dihydrotestosterone has the ability to act on the androgen receptor, which I'll talk about in a minute, that can go in and express the gene for miniaturization of the follicle. So to get a more global view of this, we're going to show an androgen receptor as an enzyme here. It has an active site, let's just view DHT as a square, that physically fits within the androgen receptor. And here's the nucleus. So, in our case, say this is a cell that is in the lining of the hair follicle. In our case, what happens is testosterone comes in, is converted by 5-alpha reductase into DHT. Now there are actually two isoenzymes of 5-alpha reductase. There's consequently two variations of DHT, type 1 and type 2, which are isomers of one another. Same exact chemical compound, but different spatial arrangement, kind of like your hands. While they both have the exact same composition, they are different in the fact that one is arranged differently. So those are what isomers are. But let's just focus on the basic principles here. So testosterone comes in, goes to DHT. DHT can bind with the androgen receptor, and then this complex can move into the nucleus, and based on the central dogma of biology, it can cause expression of genes which create proteins, create things that signal the miniaturization of the follicle. So it is by this process that miniaturization occurs. So I'm not going to get into treatments too much, but you can already begin to picture some of the possibilities of stopping this process. And along that note, I would also like to throw in the fact that males that have a deficiency of 5-alpha reductase, or that were castrated so that dihydrotestosterone was not present within their systems, would not express male pattern baldness. And they compared this in terms of twins, where one could be castrated and the other wouldn't. So we both know that they would express the male pattern baldness gene, but those individuals who were not producing dihydrotestosterone would not express male pattern baldness. So we do know that DHT has a huge impact on this process carrying out, or the miniaturization of the follicle. And as I was saying, this occurs in certain patterns. If you've ever heard of the Norwood-Hamilton scale, this is just a impossible for you to see at this distance, but I've still put it up here just to kind of guide me. So check that out online. This just shows us an expression or the general progression of different types of hair loss and how they might present themselves. As we know, in individuals with male pattern baldness, there are a bunch of different factors to be concerned about. First of all, they have a higher concentration of androgen receptors within the hair follicles than would normal people. And usually those androgen receptors are more sensitive to dihydrotestosterone, whereas the androgen receptors of people without male pattern baldness would not be as sensitive. Another aspect of this is that simply people without male pattern baldness may go through the same exact process here of T binding with the androgen receptor, but simply the gene that it expressed won't go to miniaturization of the follicle. So there are a lot of different levels, and there are a lot of different factors that contribute to male pattern baldness. So it's not a very simple science, and there are a lot of gray areas, and there's surprisingly a lot of unanswered questions out there about basic fundamental things about how it works. But our best understanding is this scheme here, where there is testosterone that is converted into a more potent form that combined with the androgen receptor that expresses a gene for miniaturization. You should also note that the androgen receptor also has an affinity for testosterone and some other androgens, but it has the greatest affinity for dihydrotestosterone. Thus, dihydrotestosterone is most prominent in the expression of male pattern baldness. So with that said, it is very apparent that there are many genetic factors involved with male pattern baldness. And a lot of the science in the past shows that there is strong linkage to the maternal side of your family. Because, and the theory behind this is simply because the gene for coding or making this protein, the androgen receptor, is found on the X chromosome, which your mother has 2 X chromosomes, and you as a male have an X and a Y. So you get your X chromosome from your mother, and it is a recessive trait. So while your mother may not be experiencing any hair loss, she has one good variant of the androgen receptor gene, which she is using, and there is also a bad one. And you have a 50-50 chance of inheriting that based on if you get her good gene, which has no variation or mutation of the androgen receptor expression, or you could get the bad gene, which carries this component of male pattern baldness. And that's something I'd like you to realize, that the whole maternal thing is just one component of it. There are actually many chromosomes and factors that you can get from the paternal side as well. And this is the huge gray area that I've been talking about. And I like to bring this up just so you guys know kind of my impending doom. These are some photos of my maternal grandfather, who's Norwood 7. So I do know if I have inherited this bad X chromosome for the androgen receptor, that there's good chances that mine will progress to Norwood 7. And based on my my diffuse thinning in that pattern, I do believe that that is the case. So we do need to realize that it's a polygenomic issue, and it's not just as simple as, does your maternal grandfather have it? There are a lot of factors, and there are a lot of gray areas. This is our best understanding. So with that said, this kind of is giving you guys a little basic understanding of how kind of the science behind hair loss. And in the next video series, or in the next video, I will be talking about what currently is available to stop this process of miniaturization, what treatment options are available, and present some treatment options that you may not know about yet, that aren't very typical, that aren't very standard. There's a huge organization of people on the internet that have really dug into the science and found answers that aren't available to the general public. So with that said, there are a lot more options out there than you might initially know of. And that's what I will be talking about in the next few video series, are some of these options for treatment that are really, they really do exist, and they are really beneficial at stopping your hair loss. So with this said, I think you guys got a basic understanding, and stay tuned to the next few videos. Thank you.